In this movie, we're going to take a look at a number of other ways in which we can use regular expressions. And we're going to explore some of the more complex syntax that we can use within our regular expressions. We're going to use the same format here of script, except that we're storing the regular expression within this variable here, and then simply referencing the variable within this function. But it works in exactly the same way. One way that we can choose multiple patterns within a regular expression is to use an operator like this. The same operator that we use within our PHP scripts, normally double to mean or, we use on its own within a regular expression, and it means pretty much the same thing as it does when we use it to mean or. This, for instance, will return true if any of these strings are found within the sentence string. So in this case, if we test in our browser, the regular expression was found. That's because it found thank you within the sentence string. If we'd have used thanks, it would have worked just as well. We can use the normal brackets if we wish to divide off an or part of our regular expression from any other part. For instance, if we wanted to find any of the days of the week, we could simply split them up like this. And that would find any of the days of the week. For instance, if we included Saturday, it's found that regular expression too. The reason is that it found this part of the string and then it matched it to this part. It would have worked equally well for Thursday or any other day of the week. Another thing we can use within regular expressions is a wildcard symbol, and this is the dot. Similar to the concatenation operator that we've used in our normal PHP scripts, it means something quite different within a regular expression. Say if we used this string, the and then a space and then dot and then O and then P. Now that will match it's the cops, because this dot can stand for any character. So in this case, C can be used to stand in for this dot. So if we check that in our browser, it's found the regular expression. It's accepted that regular expression as true when compared to this string. However, if we were to say it's the chops, for instance, and try that in our browser, we'll find that it's not happy with that. The reason for that is that this dot here only stands for one character. If we wanted to let it stand for one character or more, we could use the plus operator. And if we save that and check in our browser, we'll find that now it's accepted it, because it would allow one or more of any character, in which case this would be CH. We can also use the wildcard character to specify, for instance, the number of characters in the entire string. If we use our beginning of the string operator, then a dot, and then by using these curly brackets we specify how many wildcard characters we want to find, i.e. any character at all, we could say 10 characters. And then we need to put this $sign at the end. And these two symbols together will lock the rest of the regular expression in here to each end of the string. So this effectively says that for any string with only 10 characters, no more and no less, the regular expression will evaluate true. We can also use square brackets if we wish to specify certain characters that can stand in the place of a character, but say that any other character will not evaluate to true. So for instance, this will allow us to evaluate the cat as true, the hat as true, and the bat as true, but not the vat. The vat would evaluate to false, because V is not any one of these characters. And also, this would evaluate to false, because although we have a C and an H, both of which are in here, the square brackets only stand for one character. If we wanted it to stand for more than one character, we could add a plus, as we did with the wildcard character. We could also use ranges of characters, such as A to Z will show any of the lowercase characters, or A to Z will specify any of the uppercase characters. If we want to specify any letter at all, we can use this. This specifies either a character within the range lowercase a to lowercase z, or a character within the range uppercase A to uppercase Z. We can also use within the square brackets this symbol, and this symbol allows us to specify that whatever we've said apart from it within the square brackets we want to reverse. It's the equivalent of the not or bang symbol that we use within our regular PHP scripts. So in other words, what it's looking for there is something that's not a letter. So the 8AT, that would be acceptable, but the BAT, that would not be acceptable. Things can get a little complicated when we wish to use some of the special characters that are prescribed for use within regular expression syntax. So for instance, this regular expression, A, then the plus symbol, and then B, will evaluate this as true, or this, or any number of A's followed by B. However, we simply put in A plus B, go to our browser, it's failed. Now this seems quite counterintuitive, because surely within that sentence, clearly these sequence of characters have been found. Well, the reason for that is that this plus symbol is evaluated to mean what the special character means within regular expression syntax. We use the backslash character to escape the character immediately following it. So what that tells PHP is that this plus sign is to be treated as a literal plus sign and not to say anything about the number of A's that we're allowed to use within our sentence. So to take a quick look at that in the browser, it's found the regular expression successfully. We can do the same. We can use the backslash character to escape any other of our special characters, such as curly brackets, normal brackets, any of the characters that you've learned in these last two movies. Again, this is quite a lot to digest, and I suggest that you take the time to have a play with regular expressions. And in our next movie, which is going to be a short one, we're just going to have a look at a way of using regular expressions to replace variable strings within a string. After those last two heavyweight chapters on regular expressions, I think you deserve a bit of a reward. So I've split off the ereg replace function and given it its own short movie at the end of this chapter. The ereg replace function works quite similarly to the str replace function, but is a lot more powerful. Let's take a look at an example. Within our sentence string this time, there are a number of different color words, all the words for colors, and let's say we want to replace all the different colors with one single color. Let's say that's our favorite color, and we want to change all the color words to that. We can use ereg replace to do that very simply. First argument that this takes is the regular expression that we want to use. So in this case, I'm going to put in all the colors and then second argument is the string that we want ereg replace to work on. Now, whereas in str replace we'd search for this string of characters literally, ereg replace allows us to search for a regular expression pattern and replace all instances of that pattern with whatever string we want to replace it with. In this case, we're going to replace it with the color blue, which is the second argument, and the third argument is the string that we want the ereg replace function to act on. Let's save that, and we'll go to the browser and have a look at what that does. As we can see, it's replaced the colors, orange and purple and so on, and green, with the word blue. I've included this rather nonsensical example here, just as a little reminder that computers in general, and programming in specific, is never reasonable. We have to do all the reasoning, and computers will just follow it very faithfully and logically no matter what kind of nonsense it's going to spew out at the end. However, we can see that ereg replace is a very simple way of replacing regular expressions with a string of our choosing. In this chapter, we're going to be looking at one of the most useful and important parts of a scripting language such as PHP, and that is database connectivity. We're going to be looking at the ways in which we can connect to our database and query it to bring back data that we can use within our scripts. And then we're going to be looking at ways to handle that data once it gets back to our PHP script. In this chapter, and in most of this title, we're going to be looking at a database called MySQL. Now, there are a lot of different relational database management systems available that we could use. We're using MySQL as an example because PHP has native support for MySQL. It also has native support for many other databases. MySQL is a good example because it's available under an open source agreement, or at a relatively low cost for a commercial license, and is often seen as a natural partner to PHP. We're also going to look at a couple of examples of connecting and querying other databases such as Microsoft SQL Server and PostgreSQL. You should also be aware that there are many other relational database management systems that PHP uses and that you can use with your PHP scripts. Let's take a look at the sample database that I've created for use within this chapter. We're going to have a look on the MySQL command line, and we're going to have a look at the Vinyl Dealers database. Now, this database that I've made is a very simple little database that simply stores a number of fictitious sellers of dance music, shops within a fictitious town somewhere in Australia. So there's various tables within the Vinyl Dealers database that we're going to have a look at. There's three tables. There's the shops table, which just lists all the shops and the details of the shops, and then there's the genres table, which lists all the different kind of music genres, so that we can later on choose to list by all the shops that specialize in a certain genre of music. And then there's a shop genres table in the middle, and what that does is that's a many-to-many, that performs a kind of many-to-many relationship between the two other tables. Well, let's take a look quickly at the different tables that I've made here so that you'll be familiar with them as we move through the rest of the examples in this chapter. If we take a look at the shops table, there we can see primary index and the name of the shop and various other details down there. Take a look at the genres. As we can see, just an ID and a name. And if we take a look at the data in that, taking my syntax there, we can see that there they're listed all the different genres that we're going to be looking at, dance music. And then if we have a look at the shop genres table, we can see that there's just two keys, foreign keys, listed there, neither of which need to be unique, and this is used to connect the other two tables. You can find the SQL file which you can use to create the database on your own system if you're using MySQL on the CD in the examples folder. In our next movie, we're going to take a look at a way to... So we've taken a look at the structure of our sample database, Vinyl Dealers. Now we're going to look at ways to connect using PHP to the database and to select a database from it. And we're going to perform a short query within our script to test that we've done those things successfully. We start out by making a connection to the database. The way we do that is to declare a variable, we'll call it db, and then we'll set it to the result of this function, MySQL connect. And MySQL connect, don't forget the underscore between the two words to spell the function correctly. This function takes 3 arguments, first of which is the host name, and because it's localhost is a host name, we can safely, for the moment, while we're developing on our local machine and no networking is involved, we can safely leave out the other 2 arguments, which would be the port and the password. So we can just give that 1 argument for the moment, and the result of this function is set to this value of this variable. Then we're going to use another PHP database function called MySQL select DB. And you'll notice that the name of the specific database that we're using, in this case MySQL, is included within the function name. The reason for this is that PHP has the capability to access a wide variety of different databases and has support for a lot of these databases through inbuilt functions such as MySQL connect. And there are similar parallel functions, although not necessarily the same syntax, with a whole load of different databases. That's why we're using MySQL connect to specify, because we're using a MySQL database in this case. MySQL select DB takes two arguments, first of which is the name of the database that we wish to select, and the second is the connection that we wish to use to select that database. In this case, it's DB, which is the connection we specified in this line. This argument is optional. If we left it out, PHP would look for the last connection that was defined, in this case DB, and use that. So in this example, we could just as well leave out that particular argument. But for the sake of clarity, I'll leave that one in. And then to test that the connection has been made and we've successfully selected the correct database, we're going to perform a short query. We're going to use a very simple bit of structured query language, SQL, which is going to select all the data from the shops table. And we're going to assign this to variable query. Now, all that's being assigned here is simply this string of characters here. It doesn't, this line does not in any way perform a query on any database. All it does is set this set of text to this string variable. In order to get the query to be carried out, we need to define another variable and use a function called MySQL query, which does pretty much what you would expect it to do. It carries out the query on the selected database using the string of SQL specified as the argument that it takes. In this case, select everything from the shops table. Next, we're going to use a very simple PHP function to make sure that the connection has been made and the query has been carried out successfully. So in this case, we're going to just take the name of the table from a particular field. In this case, the first field in result. which is the result of this query. And all this function does, MySQL field table, is it returns the name of the table that the field that we specify here is taken from. You don't need to worry about this function right at the moment. All we're using it for is just to check that the other stuff that we've done in this script is actually working. So we're going to echo table variable to the browser. So let's save that. And all that's being echoed to the browser is the name of the table. So if any of this has gone wrong, then we'll get nothing echoed to the browser, or the wrong table name or something. And if it works, then we're going to get the name shops. So let's test it. Go to our browser, and we've got the address in there, so we can just hit refresh, and we get the table name shops. So we've successfully connected to our database, selected the database that we want to use, and we've run a short query, and we've checked that that's successful. In our next movie, we're going to look at more useful things that you can do with PHP's database connectivity to connect to our database using PHP. So far, our script has successfully connected to the database and selected the particular database that we want to use, but we haven't got any output from our query apart from the name of the table, which is not very useful. So let's take a look at ways to output some data from the database. What we use, now that we've got our result of our query here, is a function called MySQL fetch row. Now what that does is it returns a numerically indexed array which we can use to access the data. So for a numerically indexed array, if you remember, we could use a loop to go through and access all the elements within the array. However, there are a number of different rows as a result of the query. Each row represents one row within the database. So the way we loop through all the different rows to act on those is we can simply use a while loop. And we'll set a variable, let's say record, to the value of the result of this function, MySQL fetch row, and we're going to do that from the result of the query, so that if this executes successfully, that means that data has been returned and has been assigned to record. If it doesn't work, that means that no data has been assigned to record, and this while loop will stop. So now we've got the record variable containing a row from the results, and we're going to have to loop through that to check every element within the row, so every column within the row, essentially. So let's use a for loop, similar to the ones we've used before, and that's going to go through the length of the number of elements within the result array, and every time it finds one, it's going to echo this element on its own to the browser. And let's put in another line break over here. This is so that the different records will be split up from each other. And finally we finish our while loop with another curly bracket. Let's save that and see what our MySQL fetch row has done for this PHP script. As we can see, the data is being output now. We've successfully used our PHP script to access the data within our database, and it's being output in a rather random way. Well, it's not random, but it's not very structured in terms of how the user is being presented with the data. There are a lot of empty spaces, and although we've got all the data here, we don't know what any of these are. Maybe a little common sense could tell us that this is the email, but one of these two figures is the phone and one of these is the fax, and we're not being told. So that's not very useful. If we go back to our PHP script, there's another more useful way to do this, which involves associative arrays. Now, the change that we need to make here is to use a different PHP function called MySQL fetch assoc for an associative array. Now this, of course, we won't be able to use this for loop, because as we found out in the last chapter, for loops will only work with numerically indexed arrays. So what we'll use is another while loop, and we're going to use that list function that we learned about in the last chapter, the list and each functions, to find the key and the value of each element within the associative array. So we're going to say field name can be the name of the key, and field value can be the name of the value. And we're going to act on the record associative array. This works very similarly to the example in the last chapter. We're going to output to the browser the field name and then concatenation symbol and a quote there, and then we're going to put in simply a colon and a space to separate them, and then the field value. And we shouldn't forget to put in another HTML tag within double quotes as always. And we'll close that in a while loop. So where before we had a for loop within a while loop, here we have two while loops, but it's doing pretty much the same thing. The outer one loops through all the different rows within the result of the query that we specified, while this inner loop here loops through all the elements within the array that we fetched for each row. Let's take a look at how that's working. If we refresh our browser, we'll see that this time it's included the keys, each of the keys, and where there's a blank field with nothing in it, the key is still specified, so we can see what is missing from there. Phone and fax, it's obvious which one's which, and the data is generally presented in a much more useful way. Once again, I suggest you take the opportunity to have a play around with these new ideas, try out some queries of your own on the sample database or on your own database,